Hello everybody, welcome to our presentation on the Carson City Airport Main Apron Reconstruction Phase 3. We'd like to start off by presenting our project team. Hello everyone, my name is Jacob Shadell. I was the project manager for this project. I was responsible for the estimate, the pricing worksheet, PCC paving plan and associated details, and also the AgTech earthwork model.
I'm Dave Rodriguez, one of the project engineers. I was responsible for the estimate, the schedule, the SWIP, and the traffic control.
My name is Brandon Ballard. I was the other project engineer on this job. My responsibilities included estimates, developing the quality control program, project phasing, and excavation drawings.
To start off with an overview of this project, it consists of removing and replacing approximately 17,000 square yards of an existing aircraft apron. This is one phase of a multi-phase contract that intends to revitalize the aging infrastructure at the Carson City Airport and bring more economic viability to the airport. The current site consists of 2 and 4-inch AC on approximately 4 inches of aggregate base. We will be milling this in place and then stockpiling it on site for future use in our structural section. Once all removals are complete, we will have to export approximately 5,000 yards of cut to another on-site stockpile for use on future projects. Once we have our subgrade made and our recycled bases in place, we will pave the entire AC area, which is in the purple and the blue. The purple area is AC touch strip, which must be completed first and approved by the RE before we can pave anything else. We will pave past the limits of the PCC in the green, and then come back later and saw cut and remove the overpaved area. The overpave reduces the number of forms we need for the PCC pour and gives us a clean edge. Once the AC is in place, we will saw cut and excavate for the new 24-inch slotted CMP, which is in the red, and the inlets, the Type 4 and the 36 by 36 by 48. After that, we will saw cut and excavate for the 15-inch RCP, which runs through the parking lot, which is in the purple there. And then once all our drainage and our tie downs are in place, and our PCC is poured, we will have our striping sub come in and do all our required markings. As you can see here, we were conveniently given a site access plan by the owner. In the bottom left hand corner, you will see our staging area, which is where we'll be stockpiling our recycled ag base, and also the location of our job trailers and any other stockpiled material we might have. You can also see the aircraft access points and the access that we need to leave open for aircraft so they can get to their hangars. And you can also see our truck haul routes, which will be managed by us at all times.
Now I will talk about the project schedule. The project duration was 44 days, with the first day of work on June 25th and substantial completion on August 27th. Some of the critical path activities include the removal of the existing pavement and the excavation and removal of utilities. Once all the removals are done, the following critical activities will be the pavement test strip, the placement of the asphalt concrete, and PCC. After the AC is placed, we will have to saw cut and excavate in order to place the new 24-inch slotted drain pipe that crosses over the main apron.
Per specification section 100 of the contract documents, we were required to develop a quality control program to establish, provide, and maintain quality control throughout the project. The intent of this program is to provide for production of acceptable quality materials, provide sufficient information to assure specification compliance, and to assign responsibility to project participants. And for the project responsibility, we developed a table, as you can see shown in the image on the right. Jacob Scheidel, who is the project manager on the project, is responsible for just general contract oversight within the quality control specification section. Myself, I was acting as the quality control manager, basically mentoring and coaching for all QA and QC throughout the project. Roman Garcia works for AMTI, who is our consultant for all quality control testing for the project, and his responsibilities are to administer and oversee quality control testing. James Wilson, also an AMTI employee, was our geotechnical manager to review any geotechnical data as far as quality control was concerned. And Dale Pride, also AMTI, was our field inspection and quality control manager for observing all testing and making sure things were getting done properly and in compliance with the specifications.
SWIP. We developed a stormwater pollution prevention plan for the project in order to comply with Nevada's general permit for stormwater discharges with construction and land disturbances activities. This project was a risk level 1, meaning that the project had a low receiving water risk and low sediment risk. To mitigate that risk, we also developed an erosion control plan that included BMPs such as temporary fiber rolls, temporary check dams, and storm drain inlet protection to effectively reduce or eliminate pollutants in stormwater discharges from construction activities. As you can see in this image, we have check dams in our swell and fiber rolls all around the main apron, where most of the construction will be taking place. We also have 2 stabilized construction entrances on the staging area, as well as a concrete washout and a stockpile area protected with visqueen and sandbags. Traffic control. The purpose of developing a traffic control plan is to be able to manage all vehicles entering and exiting the site to ensure everyone's safety. One of the most important parts of this traffic control plan is located on the East College Parkway, where the new 15-inch RCP will be connected to the existing 42-inch RCP. This is due to the public traffic and pedestrians on the street. The image on your left shows the flaggers that will be directing traffic and informing drivers of detour routes. The image on your right shows the traffic control plan that will be on the East Coast Parkway that will allow us to work with the public right-of-way efficiently while maintaining safety.
For the project phasing, originally we were required per the specifications, special provision number 10, to break out the project into 2 phases, phase 3A for the main apron and phase 3B for the taxiway connector. And the reasoning for that was to prevent aircraft from entering the work zone. But what we proposed to do was in order to increase productivity and efficiency, we combined phase 3A and 3B into one phase and placed K-rail barricades at the taxiway connector to deal with the worry of the aircrafts entering into our work area. One other addition, there was an ad alternate for taxiway work, and for phasing that work, we proposed that all of that work associated was to be performed at night during phase 3, and opposite ends of the runway were going to be completed in different shifts per the notes on the phasing plan.
For this project, we developed a earthwork model using a program called AgTech. This gives us a 3D surface of our cut fill area and allows us to see where our max cuts are and how the dirt is moving exactly. As you can see, there's a break point up towards the north part of the lot, and this shows the designer wanted to have all the sheet flow drain into that 24-inch CMP from the break point, and then the rest of it will drain into that swale that we're grading. After the model is complete, we determined that there's approximately 6,000 yards of cut, but with our reuse of the mill in place, we came up with about 5,000 yards of export.
There was about 390 lineal feet of 15-inch reinforced concrete pipe on this project. For the excavation, we were able to open cut 144 lineal feet. The soil reports told us that it was type B soil, so 1-to-1 slope was acceptable, with a max depth of 10 feet. And for the remaining 243 lineal feet, we used trench shields, 4-foot by 16-foot trench shields. And overall, the excavation for this 15-inch reinforced concrete pipe was about 1,100 cubic yards of soil.
With the CMP detail that we were provided with in the original contract documents, you can see on the left, we're required to encase the CMP in 4,000 psi concrete, but this brings us with the issue of how you support that while you backfill it. And to solve this problem, we came up with using 4x4 dunnage along with a half-inch steel strapping to support the CMP every 20 feet or so. This allows the CMP to be held in place both vertically and horizontally in the location that we want, and then it also allows the CMP not to float once you start backfilling with concrete, because it will want to push up. This is just one example of some temporary structures we have in the project. The original contract documents for the PCC details, we were given this detail on the left, which is the dowels for the thickened edge. This requires us to drill and bond into the thickened edge and then have the dowel painted and oiled for the slab next to it. We see major inefficiencies with this because it requires us to pour the whole perimeter first and then come back and drill and bond. To maximize our efficiency, we provided the detail on the left, which uses dowel baskets in place. This allows us to pave our PCC in lanes, and it still fulfills all the requirements of the design, leaving one end is fixed and the other one is loose. As you can see in the bottom left, the infield joints receive the same kind of treatment, which fulfills all the contract requirements. With the new dowel details and the overpave, we came up with this pour plan. So after we come back and saw cut for our overpave, you can see pour 1 is the purple areas. These will be paved in 20-foot wide sections, so we have a 20-foot screed. We'll place all our field dowels in baskets and then come back and pour this. This is the most efficient because it only leaves one edge form for the first lane and then 2 edge forms for the other lane, and then after that we won't need to form anything at all. This was our most efficient approach we could come up with. To wrap up our presentation, we'd like to show what we think separates us from our competitors, and the first one is the use of our recycled aggregate base. This reduces the amount you need to import and export, and is also more environmentally friendly plan. We also see the revised phasing in our PCC pour plan as ways that we increase our production and our efficiencies. And last, we see our quality control plan as a way that we can guarantee that we can reduce our rework costs and can eliminate anything that we might need to fix. In conclusion, thank you for watching our presentation.